Now, I add 5 onto register 5, so it becomes 3026. The reason for that is that I'm going to build my string from the end back to the beginning. See, I've initialized the string here with spaces. This is the ASCII code for a space. And so I have filled my string with spaces, except for this one down here. That's my string terminator. And so now I have 3026 on there. Register 5 is pointing at this location. That's where the units digit of my number is going to end up. And then I'll just build it back up through the list as we go. Okay. Well, that gets us down to here. Now then, I load register 0 with my value. Well, for the sake of discussion, let's say that it's 126 hex. Let's see, we use our scheme for conversion. Times 16 plus the last digit in decimal. That's what I should be coming up with. I should end up with characters to print out 291. So we'll just keep track of that. Now, I probably should have taken well, let's do, just so you can see how this thing works. Suppose I want the negative of that number. That happens to be minus 126, or minus 291. Let's see what happens if we do that. This load is going to set the end bit, because the most significant bit of the number is a 1. So it says, oh, this is a negative number. Okay, what are we going to do? Well, we will not take this branch. So now we look at this thing, F, E, D, A. Not says you change all those bits. And so in hex, I now end up with 0125. After this instruction. This says add 1 onto it, so I get 0126. This clears register 1, so I get a 0 in register 1 out of this AND. Add 1 to it, so now I've got a 1 there, and I store that in location flag. Let's see, we're going to want to keep track of these things. String looks like this. flag now is gonna have a 1 in it. That's just a way of remembering that my number is negative, but I want to work with it as I start trying to find the digits, work with it as a positive number. Okay, so I store that at flag. Now, we subtract 1 from our stack pointer. So we're now at 2FFF. And I store a value out there. Hard to keep track of all of this stuff. Okay, here's my stack. Here's 3,000, which is where my program begins. First line of my program. Okay, so I subtracted 1 from my stack pointer, got me to this, and now I store my register 0 out there. 0126. And now I'm going to jump to this subroutine. Again, I'm going to wave my hands at that. I hope we're going to have time to come back and look at it and see how it works. It's not very efficient. It's quick and dirty code. So it's not very good. But the way we had this thing set up is that it would take this value off the stack and then it will divide that 126 by 10. See if I can do this in hex. Let's see. 8 times 16 is 128. About a 1D. 10 times 13 is 130. If I convert that to base 16, it's
should be C, right? C1.
yeah, that gives me an 8-2. Subtracting, I get 4. Not the right number. One, two, 6. 18 minus 10 is 8. 130. Yeah, 4. Did I convert that number wrong?
I think the last step you added 3, but you supposed to add 6, weren't you?
Oh, yeah, that's right.
Yeah, it's 126, not 123. Okay. So we want a minus 294. Okay, so it should return the quotient down here and the remainder up here. And the stack should, as it comes back, should have 2 FFE. The stack pointer should always be the address of the top thing on the stack. Okay, so as we come back from this subroutine, this is what we should see. We should have these two values on the stack. The stack pointer is looking here, that's register 6. So now this says load register 0 using register 6 as an address, offset 0. So we load register 0 from here, we get a 4. Add 1 to register 6, so now we're at 2FFF. Okay, this is a pop routine. These two instructions together are a pop to get things off of the stack. Load register 1 from ASCII. What's down there? Well, there it is. It's a hex 30. So that's what we get in register 1 now. 30. Let's see, am I getting close enough? Yeah. Okay.
What did the divide by 10 do? Like, where did this store the results?
It divides the number by 10, puts the quotient as the first bottom entry on the stack, and the remainder is the top entry. Okay, so we load register 1 with the ASCII coding added onto register 0. So that gives us now a 3-4 down there. And store it using register 5 as the address with no offset. So I store it into location 3026. Which is right down here, last one before that 0 byte. So now I get in here a 3-4. Subtract 1 from register 5. So now we get here 3025. Add 1 to register 6. Add 1 to register 6, which gets us down to here. But now I load register 0 using register 6 as an address, but I have an offset of -1. So I go the location below this one, which is this one. Okay, so it loads register 0 with a 1D. I'm going to have to erase some things there. We're going to get into trouble. Okay, so now we have 1D. That's the thing that came off of the stack. I did that in a funny order. Instead of using register 6 with no offset, so that I could here on this test be looking at that quotient that just came back. Okay, the result was positive, so I go back up to 300A. I subtract 1 from register 6, which gets us back down now to 2FFF. I store register 0 in this location. Well, register 0 is a 1D. I don't have to erase anything, that's what's out there. Technically, I probably wouldn't have to do that, but typical way of handling anyway. And now we go to our subroutine. Okay, now, the divide by 10 thing is going to take that thing that's on the top of the stack and divide by 10. You can do this division in hex if you think about it. This is 1 times 16 plus 13. Well, 1 times 16 is 16 plus 13 is 29. 10 will go in there twice. 2 times 10 is 20. That's 1 times 16 plus 4 in base 16. Now we subtract that. 13 minus 4 is 9. Okay. Now my routine is going to put the quotient here and the remainder here. And as it returns, it's going to have register 6 set up here. Maybe we should have just gone through that. Let's turn this page over and go through that routine. I will have put 1D out here. This is the way it was when divide by 10 up here was called. Let's see what happens. Let's just go through that routine. Now, it's a lot longer than one might expect because, first of all, I've gone through the business here of saving all the registers that I'm going to work with. These are just memory locations that are set up where I can copy what was in the register into there and then get them back the way they were. So that the main program doesn't see anything changed except for the stack pointer. Okay, so we're going to ignore that. This says load register 0. Well, let's see. We better do that. Puts 1D down here. Puts a 30 here, and I don't know what in there because I haven't used register 2 in the main program. Okay, so now I load register 0 to FFF right here. Okay, so register 0 now has a 1D. Well, that happens to be what was already there, but that's coincidence as far as we're concerned. And we add 1 to register 6. We clear register 1. So we get a 0 in there. And register 1. I'm going to put a minus 10 in there. Ooh, what does a minus 10 look like? Well, 10, the easy way to find the negatives on these things, by the way, just subtract each of these digits from 15 and subtract this one from 16. It ends up being the same thing as changing all the bits from 0s to 1s and adding 1. Ends up giving you the same thing. So register 1 has this value in it. We clear register 2, and then we add 1 to it. Okay, we add register 1 to register 0. Let's see, we've got 1D and register 1 is FFF6. Okay, 13 and 6 is 19, that's 1 times 16 plus 3. 15, 16, 17, that's 1 times 16 plus 1. 0, 0, and the last carry is lost. So register 0 now has 0, 0, 1, 3. Okay, I'm all right. Now, if the result was positive, which it is, I branch back up to divide. Okay, which says I add 1 to register 2, so now I've got a 2 in there. And now I add register 1 to register 0, so I add another FFF6. 6 and 3 is 9, 15 and 1 is 16, that's out and carry 1, 16, 16. And so that ends up now in here. It's still plus, so I back up, I do it again. Get a 3, and now I add FFF6 here. 9 and 6 is 15. That's actually in register 0. But now when I hit the branch, it's not plus, it's negative. Bing. So I don't take the branch, I go down here. I add 10 onto register 0. Well, 15 and 10 is 25. Let's see, that's 1 times 16 plus 9. So I'm back to 9. I add a minus 1 to register 2. Now I store register 2 where register 6 is pointing. Oh, wait a minute. Oh, man, that's the problem. I skipped this one. I subtract 1 from register 6, which gets us to 2FFF. Now then, I store register 2 out there. That's a 2. So I'm going to get 0002. Subtract 1 again from register 6 gets us to 2FFE. And now I store register 0 out there. That's a 9. Now I get a 9 in here. Okay, now I get these registers back the way they were. Register 0 now becomes 001B, just like it was. This one becomes 0030, and register 2 to whatever it was. It was garbage, I hadn't been using it. But if I use this routine with another program, there might be something in register 2. Okay, return. So now I go back to the main program. I have just returned from divide by 10. I'm now right here. So I load register 0 from 2FFE. That's a 9. So now, gotta get all this back where it was. and add one to register 6. So that gets us to 2 FFF. Load register 1 from ASCII, well, that's what's there already, but it could have been changed. We add register 1 and register 0 together with the result here, so it becomes 0039. Right there. And we store it in the location whose address is in register 5. That's 3025. That's this one. So now we get a 39 in there. Okay, that's the way the divide by 10 routine works. You see, you have to be really cautious that it doesn't mess up your anything in the main program. Now we pop the quotient into register 0, and that's 2, and this now goes back to 3000 when we pop it. This result is still positive, so I do it again. Now, the next time through the divide by 10, we're going to have a quotient of 0 and a remainder of 2. So to kind of shortcut here, because we're running out of time, we're going to get our 2 in there. Not 2, 2, though, it's 3, 2. Okay, basically then we're here. I load register 0 from flag. I can't remember where we wrote it down, right here. Flag has a 1 in it, so that actually comes into here. It's not 0, so I do not branch. That says now I load register 0 from memory location minus, which is right here. It has a 2D. And I store that, register 5, yeah, I skipped this thing, I didn't take -1 on that. And I'm actually now down to 2, 3. I store that in here. This is the character minus, this is a character 2, this is a 9, this is a 4, and this is what we call a null character. So after I've stored that there, now I get the actual address of string, which is 3021 in the register 5. I push that out on the stack. I decrement this down to 2 FFF and store it out there, and then I jump to the print routine, which, just to make a really quick look at the print routine, it's actually pretty short. Again, I save a couple of registers just to be sure that they don't get messed up. I pop the stack to get the address, the starting address of the string I'm supposed to print out. And then I load a character into register 0 using that address. If it's a 0 byte, that null character at the end, I'm going to jump out and I'm done. Otherwise, I use the out routine to print that character that's in register 0. Bing, there's that first character, a space. I add 1 to register 1 so that now I'm looking at the next character in the string, load it into register 0, print it if it's not a null character, and so on. once you get that null character up there, you jump down to quit, where you restore the registers and return. There it is. Now, you may want to look at that print routine carefully, because I think you can probably use it on this assignment.